You know that moment when you upload a picture to social media and boom, it instantly suggests who to tag? It feels like actual magic, right? Well, today, we're going to pull back the curtain on that magic trick and take a look at how a computer actually learns to recognize a human face. So, that really is the big question, isn't it? How can a bunch of code look at a photo and say, oh, I know who that is? It's a really deep and fascinating process. And the answer, well, it all starts with understanding that a computer sees the world in a way that's completely alien to how we do.
Right. So when you and I look at a picture, we see people, we see places, objects, our brains are just wired for it. A computer, on the other hand, it sees something way more basic. Honestly, it's a lot less romantic. It just sees data, pure numbers.
Just look at the difference here. We see an eye, with all its detail and life. The computer, it just sees a grid of numbers. And each number in that grid is just a value that tells the machine how bright one specific point in the image is. That's it. It's a world of numbers, not things.
Let's break that down even more. Every single digital picture is made up of these tiny little dots called pixels. Now, for a simple black and white image, each pixel just needs one number for its brightness. But for a color photo, every pixel needs three numbers, one for red, one for green, and one for blue. The computer sees millions of these numbers, and that's the entire picture to the machine. And that, right there, leads us to a huge challenge. If a computer only sees numbers, how in the world does it handle the incredible amount of them in just one single image? We are not talking about a few data points here. We're talking about millions.
Think about it. A pretty standard photo, maybe 1,000 by 1,000 pixels. Well, that's 1,000,000 pixels right there. And if it's in color, remember, 3 numbers per pixel. That's 3 million individual inputs the computer has to process just to see one photo. So the question is, how can any system possibly make sense of that much raw data?
To put that number into perspective, imagine you're trying to predict t-shirt sales. You might look at, 4 things? Price, shipping cost, marketing maybe. That's 4 inputs. For face recognition, we're dealing with over 3 million. The scale is it's astronomical. You can't just write simple rules for that. You need a much, much smarter system. And that smarter system, that's a neural network. Probably the best way to think about it is like a really specialized assembly line. It takes in those millions of pixel numbers at the start, and then step by step, it builds them into a final recognizable answer.
So here's how this incredible assembly line actually builds understanding. At the very beginning, the first set of neurons, the first workers on the line, they just learn to spot really basic things like simple edges or a change in color. Then the next layer takes those edges and learns how to combine them into more complex shapes, like an eye or the curve of a nose. Then, further down the line, other layers learn to assemble those parts into whole face shapes, until at the very end, the final layer can say, ah, I know whose face that is. So how does each layer know what to look for? I mean, does a programmer sit there and write code to define what an eye looks like in pixels? The answer is a hard no. And this is where the real breakthrough, the really cool part happens. The system actually learns this stuff on its own. This quote just perfectly captures the idea. As the person building this, you don't have to manually program all those middle layers. You don't have to figure out the perfect mathematical way to define a nose. You just let the network figure it out all by itself. And this whole process has a name you've definitely heard: machine learning. Instead of giving the computer a rigid step-by-step set of instructions, you give it a goal and a massive pile of data. And then it just works backward to figure out the patterns and create its own instructions for getting to that goal. The learning process itself is, in concept, pretty elegant. You just feed the neural network tons and tons of examples. You give it picture after picture, that's your input, A, and you tell it the correct answer, the person's name, that's the label, B. The algorithm just churns through thousands, even millions of these examples, adjusting its own internal wiring until it gets really, really good at matching A to B. So let's just quickly recap the big ideas here. First, computers don't see images. They see grids of numbers called pixels. Second, neural networks are like assembly lines that process these millions of numbers and layers, going from simple to complex. And finally, the whole magic of it all isn't really magic. It's the learning process. And that process is fueled by a whole lot of data. This technology is already reshaping our world, from how we unlock our phones to how doctors can spot diseases in scans. So the final question I want to leave you with is this. Now that we've given machines the ability to see, What else are they going to learn to recognize, and how is that going to shape our future?